Okay, welcome everyone. There are, for the new folks here, there are some useful links we always put up at the start. They're kind of to all the common places we go to in the MicroPython world. There's forums and there's Discord channels and there's a wiki which we are trying to put a bit more information into. So yeah, but MicroPython.org is the easiest place to go to, easiest place to remember. Although a lot happens in GitHub. If you can sponsor MicroPython, please do it. As Damien said, it helps keep it going. The agenda, you already know this, right? Damien's talked and I'm about to. So I'm going to reach out and thank Barry from the future for putting the video together. He did a great job last month, turned it around really quickly. So thanks, Barry. You can find those on the MicroPython YouTube channel. It's just at MicroPython, YouTube/@MicroPython. So headlines. Damien's already taken stolen all of my thunder. I actually had a whole list of things here. Damien's like, oh, actually, I think I can talk about 121. Great, Damien. But the other one I wanted to tackle was Tim Hanowich. So Tim's actually going to hopefully talk next month, and I'll talk about that perhaps toward the end of the news roundup. But it's worth taking a look at his quadcopter. This is a thing that he's entirely built. It's programmed by MicroPython. It's got an RP2040 as the brain of it, and he's wired in a radio receiver into it, which has UART. He's built a flight controller. There's an IMU and a gyroscope on this thing, so he's got all sorts of filtering and PID and all this kind of stuff. The best thing about this is he's written it all up in a lot of detail and provided all the code, so you can go through the journey with him. And it was quite a big deal. It took him, it says down there, 70 days and almost 1,200 commits before he could get this successfully flying. And he's also got a couple of injuries to his fingers. But, really impressive project, and there's some photos here, and I really like the safety first attitude, which is pretty cool. We got strings around his ottoman to make sure it didn't fly off, and then he upgraded to the pots and pans solution, which I thought was great. But yeah, really impressive project. Really impressive to see how he put it together. I might skip this one for time if I can figure out how to get the next slide. That's going to play it. Right. There we go. Because this one has most of the same things, but I don't know how well this is going to translate to the video, but you can sort of see there's a lot of failed attempts. But I really related to this. Guys, I'll let you watch it yourselves, but skip to the end. It actually does fly. That's pretty cool. So I'll stop there. Congratulations to Tim for getting that working. It's a huge effort. And we'll talk a little bit more about that later if we can skip. It's really hard to make this thing skip when it's good. No, it's good. Okay, right. So that was Tim. My new hardware. Last month I talked about that board, which was the React Studio, which is an H7 board, and I mentioned there are other models available. I actually went and got one of each of them. So now I've got 4 of these React Studio boards. They're all slightly different specs which are listed there. The main reason for that is that some people have started submitting board definitions for these, and they want to make sure they all worked. Plus, they're actually really useful boards to have around anyway. They're very powerful, relatively affordable. They're the most expensive one there is $20, and for a board that's got an H7 Cortex M7 on it, it's pretty amazing. I also, while I was buying from React Studio, I also picked up one of their low-end G4 boards. So if you're into the STM range, the G4 is kind of at the lower end, but it's their new lower end. Kind of overlaps a lot of the F range if you're familiar with those. This one's really at the low end for MicroPython with 32K RAM and 128K of flash. MicroPython will happily run on that, but you won't have all of the features that you might want as a development board, but as like a production board, it's quite useful. And they're cheap. These are $4. But if you want something a bit more grunty, the Blackpill is probably the sweet spot in terms of if you want something really cheap and useful. It's an F4. Yeah, but React have these boards. They're actually pretty good quality. They're cheap. It's really good to have all these options. I also bought a few things from the M5 Stack range. The H driver, which is an H bridge motor driver. It's not a little bit expensive because the TI chip in it's quite good. $34 for that unit. Comes with one of those little atoms which has got an ESP32 in it as well. And it'll become obvious why I wanted this in a sec. There's also a servo driver unit which I purchased as well, which was nice. This thing's pretty cool. It's got like a little microcontroller in it itself, little STM32F0, and that presents like an I2C interface, just so you get a bunch of registers that you can control your servos. So you just write into the registers what angle you want your servo to go to. It's something I didn't realize when I bought this, is that you can actually put each of those triplets of pins in different modes. So they can actually just be, they can drive NeoPixels, or they can drive digital IOs or ADCs. So that was a neat surprise. And so I bought these couple of things and a couple of other bits and pieces because you guys have seen my dad appear on this stream every so often. He's been working on this boat for a little while, and it was originally steam powered. He built like a steam boiler and pistons and whatnot. He's ripped that out, and now he wants to actually make this thing go on water. So he asked if we could figure out how to drive it. So he had a 12-volt motor, and he wants to control the rudder with a servo. So for those who are in the room here, you can see I've got this wired together, and I'm still working on that. But there's my I'm sure I could have made this a little neater before I took a photo, but yeah, we've got the motor driving and the servo turning, and it all hangs together, and it's 12-volt powered all the way through, which is pretty neat. And it took literally about 5 minutes of MicroPython code together. It took me longer to wire the thing together than to write the proof of concept software. The next thing to do is figure out how to actually control this wirelessly. That will probably take a lot longer, but still pretty fun stuff. While I was buying from M5 Stack, you throw in a few other things. One of them was the ESP32 S3 based Atom S3U that they've got now. One of these ones you can just sort of plug into any USB port and power it. It's got like a little microphone on it. It's got a little button and a LED, and it's got one of their Grove. It's like a Grove socket in its bum is the way to think of it. And you can plug in all sorts of peripherals that they offer. Also got one of these ENV units, which has what's affectionately known as the shit 40 and the BMP 280 sensors for temperature, humidity, and pressure. What else we got? Port extension base. These are all little cheap things, just a quality of life improvements, because it breaks out Grove pins really easily. $3.50, you can't go too wrong. And there was a different H-bridge unit that I bought as well, which I could have used as an alternative. Bit cheaper, but this one has one of those microcontrollers in it as well, so presents another I2C interface. Whereas the driver that I showed you before, you actually drive it directly with a PWM pin. Anyway, hardware news. SuperCon's a conference that's run by the Hackaday folks, and this year their badge is really cool, and it's MicroPython powered, so that was really cool. SuperCon's, I think it's the start of November, like 11th of November or something. And it's really cool hardware hacking conference in particular. But they often have make a big deal about putting together badges, and this one's pretty cool. A little LCD on the panel. You can't see it, but there's an RP2040 behind it. Battery powered, a couple of AA's, I think, from memory. And the idea here is they're hacking in with the PIOs and using DMA to make this look like an oscilloscope. So it's like an XY oscilloscope. You can draw things on it, and the whole front panel here is kind of like an analog oscilloscope that you can wire things into the into some of the outputs from the RP2040, and then you pull it into the inputs, and it's all pretty cool idea. And if you see some of what they're already getting out of this thing, it looks pretty amazing. And all that's happening with the PIOs is the Pico, and we can talk about what that means for those that might not know. What it does mean is that the CPU is largely unused, so MicroPython's sitting there basically as like a little application server while the rest of the board's just doing all the analog stuff. I'm hoping they get around to selling these, because it'd be a really, really cool little board. The way it works at the moment is for all the attendees of the conference, they get one of these boards. So really cool to see what people make of this. M5 Stack announced their dial, which is another one of these rotary knobs that sort of are getting popular. There's quite a high-res 240 by 240 display in a fairly small package, 1.28 inch. On the back of it's one of their M5 Stamp S3s, which is an S3 base board. Heaps of flash, very powerful. Some pretty fancy demos coming out of this thing already. So there's a little button that's like a physical button there, and that's also a touchscreen as well. So yeah, for $35, it's pretty good value, I think.
How you define the pixel? Is that a circle?
All of the circular displays, they just assume that it's like it's as if you've extended the circle into a square. So if you draw into any of the regions that are off the screen, you just don't get them. Yeah. They also released the CardP.
Like 240 by 240 through the origin.
Yes. Yeah, that's a way to think about it. Yeah. And the CardP is this small little card computer, powered by one of their S3s, again, one of those stamps. You can actually pop the thing out if you want to. And it's got a little display, and it's got a bunch of keys. There's a microphone and a little speaker in it. But it's really cool. I'm not sure what they intend to do with this, what they intend people to do with it, but I guess I think it's the kind of thing that will appeal to hackers. So it's there if you want to try it out. $30. You could drive a boat with it. Yeah, you could. I was actually thinking of using the nunchuck, but we'll talk about that later. Yeah.
MIDI controller.
Maybe MIDI controller.
Yeah.
So you're all thinking about it, right? You're all thinking about it. Yeah. And Walter is really cool. I don't know where they got the name from, but I'm curious to him. DP Technics have released this board, and I only learned afterwards. I thought, oh, it's cool. It's got this connectivity. There's a Siemens chip on here which does LTE, LTE-M, MBA, and God, I hate saying all these acronyms. MBIoT, GNSS. So it has all the sorts of things you want from a mobile little device, plus the powerful S3 that's on there as well. 16 mega flash, and it's a tiny little thing, 55 by 25 mil. I didn't realize it's pin compatible with the PyCom, with the GPy. So PyCom went out of business a little while ago, and it turns out this company must have invested in them, and they needed a replacement, and so they just decided to build their own. But it's better because it's got vanilla MicroPython, and it's got some hardware improvements. The Siemens chip that they're using is actually quite impressive. Looks great. And so, Dan, this is yours, I presume. I'm assuming it's the same Dan.
Dan? Yeah, it's the same Dan. Yes, I'm
Dan.
Dutch,
Sorry, Dan.
So it's Dan. Yes.
Apologies. Dan.
So yeah, thank you for presenting Walter here. And it's actually, as you said, last year we made some designs with the PyCom GPy, which was at the time the only small module which was actually certified to be used in commercial products. And then they unfortunately went out of business and we were stuck with nothing. So that's why we decided after some discussions on the PyCon forum to build our own module and have some improvements inside, like the newer Seconds modem that you highlighted. Also, the LTE stability has much been improved because we have a physical reset line. And of course, you all know the ESP32 S3. The main advantage with the GPy is that every I/O pin is now free to use for the application. In the past, many of the pins were shared with the modem on board, and this is not the case anymore.
Oh, that's great. Mm-hmm. I really like that you've got all the test pins available too. It's really cool for production.
Yeah, we really want to be much more open than PyCom, so the schematics are available. We don't want to make any forks of open source projects, but rather contribute to them. So we really also want to have a different mindset than PyCom when it comes to openness of the hardware. We think that's really important.
That's fantastic. I had some arguments with the PyCom folks about some of that, so that's really good.
Yes. So
sorry, I do have one question because you're advertising for 10-year support as well. Is that part of the thinking with having everything open, or?
Yeah, so
motivation?
we think so. We are an IoT development company, so we develop the building blocks, but also projects for our customers. And especially with IoT, you want your devices to have long support. So we have talked with Espressive, we've talked with Secans, and we have actually contracts with them that they can guarantee us that the products and the parts on Walter will be available for at least 10 years. Because what we've now seen with PyCom, it's something that we want to resolve for others in the future, because there's nothing worse than creating a project, investing in all the certifications, and then while having it on the market after 1 year, your main component is made end of life. So that's something that we wanted to get right just from the start.
That's great. That's really cool.
Yeah, so now the stage of the product is we are finished with all kinds of testing. We've done beta testing with about 30 testers all over the world. And we are now in pre-launch phase on crowd supply and ready for full CE FCC testing with BACL in California. I'm just writing out the documents. It's going to be sent to the test lab next week, and then it should go smooth from there on.
Ooh, good luck and congratulations.
Yeah, thank you.
Cool. Thanks, Sam. I'll push on, but that's great. I'll push on. It was, I think this came out maybe a month or two ago, but I forgot to report on it last time. The RP2040 Pi Zero, which is pretty much what it says. It's a RP2040 sitting on a board with one of the Raspberry Pi extension headers on it. So the idea here is that you can get any of the shields that you can buy for a Raspberry Pi, a full-blown Raspberry Pi, and perhaps create like a driver for it and run it on the RP2040.
Just also with that, I guess, so it's not just the header, those ports are matching up with what you get with the Pfizer. Like the HDMI and all of that.
I'm not sure they're actually mounted because they are, or they're in the same place. Oh, right. Okay, cool. Yeah, right. Actually, interestingly about these ports, like the RP2040 doesn't have support for HDMI or USB host, but there's projects to implement those with PIO. So you actually are pretty sure you can't actually implement both of them at the same time. I don't think there's enough resources to do so, but they're wired in, so it's actually a good little experimental board if you wanted to try USB host or HDMI from PIO. Yeah, for $10, it's a pretty hard one to skip on. I haven't bought one yet. PIce, again, this one came out just before the last meetup, or at least I was made aware of it just before the last meetup. But RP2040 lattice FPGA, smush them together, and you've got a PIce. So you've got about a bit over 5,000 LUTs on that FPGA. If you're an FPGA nobbin, you get a bunch of flash for both devices. So 4 meg for the RP2040 and about 12 for the lattice. All supported through open source tooling. All of the pins of the RP2040 are available, and 30 odd pins are available for the FPGA. $35. It's a good way to get into FPGA development. And I just put this one quickly. SparkFun released a tiny little 1-inch square pocket dev board, they're calling it. It's just an ESP32C6 with not much else, but there's not much else. It's still pretty useful. It's USB, you've got battery charging, and that thing can do, it's got a really cool radio on it, so Wi-Fi, BLE, and it's their first Matter in thread device for the Espressive range. So at $15, quite affordable. Let's see what.
And says we don't have MicroPython builds for C6 board.
Not yet. The stumbling block was, I can't remember what it was. We keep chipping away at it. In fact, if Andrew was got an unwell child, but Andrew often comes here. He's been working on that build, and there's a couple of compilation errors still with the C6. Yeah, it's to do with the upgrade from we're on 502 with the IDF, 502 builds just fine, but for the C6, we actually need 5.1, which actually builds fine for most of the boards. But when we try and enable it for the C6, there's some features that, due to the way we've implemented things in MicroPython, they need to be changed for 5.1. So there's a couple of things to tidy up there. Right, OLMX. So I didn't realize till yesterday, I think someone mentioned online that OLMX had a new IMX RT. They call it the 1010 Pi, but I'm pretty sure it's 1011 chip. Anyway, it's a really powerful little chip. There's this range from NXP, 500 megahertz chip, 2 mega flash, 128k RAM, €15. Really powerful little board. They say it's about 4 times faster than the RP2040, which seems probably about right. The M7's a beast. But then I looked closer again, and OLMX has a whole page on advertising MicroPython boards, and there's like 5 boards that they sell under the MicroPython link, which I had no idea of. The other thing I had no idea of, a whole bunch of this short little tweet from someone. Tweet? Do you call it a tweet or an X now? I don't know. Anyway, the NXP range has things that are like the PIOs, the RP2040, FlexIO or something. So I've got to go and figure out how they, or what they can do. But there's examples of using them to implement UARTs and stuff like that. I will push on. The Kendrite K230. So some folks might remember the K210, which is a chip used by Cyped. This one looks really grunty. It has like 2 mega RAM, 2 cores. One of them is 1.6 gig. The other one's 800 megahertz. Presumably cheap because the Kendrites usually are. So when I saw this, I was like, oh yeah, it's another chip. Okay. But then someone asked if they were going to port OpenMV, and they're like, yeah, it's already done. So apparently you can get OpenMV running on this thing and connected to the OpenMV IDE. So I went and had a look, and it looks like they've already ported MicroPython to this chipset. And I only found out about that because Analog Lam, they're a manufacturer, and they've whacked one of these Kendrite K230s on a board, and they're selling this as a development kit for about $50. There's an article on Hacks.io. This thing's super powerful, and it'd be interesting to see how that OpenMV port runs. For those that don't know, OpenMV is an effort to kind of smush together MicroPython with OpenCV. So you have a lot of what do you call that, machine vision stuff working on a MicroPython, and they've built an IDE around it, so you can do a lot of object detection, that kind of stuff through the IDE pretty readily. It's pretty cool. I'm going to keep going because we're going to get cold pizza if I'm not fast. Nordic have a couple of announcements. It's all vaporware at the moment, but it's the NRF 54 range. I guess the big thing here is they're using the Cortex M33, and they've got less power consumption. They're also targeting thread and matter. The more recent announcement was about their lower end stuff, which is still pretty high end. 1.5 mega flash, 256k RAM. Don't know what their RISC-V co-processors are doing yet. And this chipset complements their other one, which is also vaporware still from April, which is the more powerful 320 megahertz, 2 mega flash, 1 mega RAM. Curious to see how these chips fall out. Nordic makes some interesting stuff. The InkPlate 6 Motion was another an e-ink device from Soldered. They've been churning these things out. It's still coming soon, but they do have a pretty good track record of delivering. The main thing here is that you've got 11 frames per second on an e-ink device. Don't know how they're doing that exactly. I do know that they've slapped down an H7, an STM32H7. And so it's not just driven by an ESP32 as the older devices were. They've also got an ESP32 for Wi-Fi and BLE connectivity. And they've still got their InkPlate MicroPython GitHub repo that they support. So yeah, if you want something that updates quickly on e-ink, looks like a good option. We talked about the Pigo Vision last month. Andy, I'm sure you're going to comment here. I'm waiting for the little chat to go ding. It's come out, and so you can buy them now for 55 Australian. These things have 2 RP2040s in them. One of them is a Pico W, and the other one's a RP2040 dropped onto the back side of the board. They've also implemented some 2 8 meg PS RAM chips on there, and they use that for double buffering, using PIOs to access those PS RAM chips. And so this thing can generate an HDMI signal, yeah, they've also got a competition at the moment. So if you can generate something that looks cool, yeah, as Andy says, it's a fun board. It looks really cool. I'm waiting for the Yukon to come out as well. They've got another board that looks like it'll power a whole bunch of motors, and so I might wait till that one comes out and then order a couple of things from Palmerani.
You know what resolution?
You're going to ask that. It basically depends on how many colors you want, and they've got like you can offset the resolution for colors. I can't remember how much it is, Andy. If you know off the top of your head, we'll find out and get back to you. In any case, yeah. Andy said something. Not sure. Okay. Yep. Bit picky with displays too. Yeah, I think that's part of the PIO implementation. Probably will improve those. So yeah. Right. Software news. Galdiano handheld. So Angel Cabello released this thing. You can buy it on Tindy for $170. He's just kind of got like an ESP32 development board and slapped together a keyboard and then pulled a bunch of math libraries into this thing, built LVGL in this thing as well. So it's got MicroPython at the core, but he's surrounded it with a whole bunch of other libraries and got a pretty fancy calculator. And he also gave a demo of it controlling the lights in his house, just because he could. So yeah, that was interesting. Simon Priggett, who presented to us a couple of months ago, was it? Yeah, 2 months ago, I think. He's been keeping busy, and this one was an interesting one. He noticed that the Alexa skill that used to play his BBC radio through didn't show the name of the artist, didn't show who was playing, and despite the fact that information is available. So yeah, he just added to his little board and made a query, and so now he can see what's playing on the BBC radio. I thought it was a cute little thing. Best thing about this is that there's a really good write-up. He talks about how to make your own, how to get all the software sorted out. It's a really good example if you want to put together like a good README for your own project. Sorry, I've been missing chat windows. So real live screen. You won't ship to the UK. Bugger. So Andy's just saying that the calculator can't be shipped to the UK, which almost certainly means it can't be shipped to Australia. But another one of these FPGA boards that's stuck another micro on there as well, and it's a lattice, but this is the ECP range, which is a bit more grunty than the ICE 40 range. You can just see the hint of an ESP32 on the back there. This is actually a really powerful FPGA board. I can't remember how many LUTs you get on the ACPs. You can actually buy a couple of different ones for this, and something like 20 or 40,000, I think. Cool thing is that they've added a library so that you can program your FPGA from the ESP32, and this is in MicroPython. In fact, there's a defect that's listed because apparently Soft SPI has got some problem with this on 1.21, and we're not sure why yet. So stay tuned on that. We'll figure it out. If you're looking a little bit more seriously at FPGA stuff, Raph, I'm looking at you. You might be interested. Jeff Glass released a string.template library. String.template was one of the standard library features that we didn't have in MicroPython. He's now got an MP templates directory, which MP templates repository, which adds that feature. He needed it for a project he was working on. And it also required him to add a few other bits and pieces. And I've asked him if he's going to put those bits and pieces back up in the MicroPython lib, which he says he's going to. So that's great. The template feature, if you haven't used before, lets you define like a string with templates inside it, and then you can replace them at some point later on in the future. It's quite a nifty little thing, but more importantly, it's often used from other libraries that we're trying to port. So it's good to have that there. Makes it easy to port some other libraries. Quick bites. Colin Dietrich gave a presentation at PyCascades from a little while ago talking about writing an I2C sensor driver in MicroPython, worth a watch. It's also good because he's someone who's not an embedded person. He's like a data scientist, and he's just managed to figure these things out. And it's good to hear that perspective. Elliot Williams, who's the editor-in-chief at Hackaday, wrote Close to the Metal, which is talking about some of the work he was doing with Hackaday Supercom badge. But it was really interesting to hear how he was talking about how it was great being able to use a high-level language, but to use the machine.mem32 functions to actually write up registers and sort of unlock some of the low-level features of a micro. So that was pretty cool. I've also got into an argument with a few people on that, if you want to chime in. People are annoying. MicroPython is now, or at least will soon be on the Sega Dreamcast. So, welcome to the late 80s, early 90s, I'm not sure, something like that. Anyways, apparently there's a group of retro people who are doing Callisti OS, which is an OS that can run, or at least can develop for the Dreamcast. MicroPython's now been ported to it, so that's pretty cool. Last month we talked about a VS Code extension to Raspberry Pi Pico programming with MicroPython. The Random Nerd Tutorials folks have put together a really good write-up on how to use that. Check it out. Final thoughts, what have I got here? Oh, I haven't even seen this yet. This came in just as we were talking, but Russ Hughes apparently got some fonts going on the TTGo T display. So, great. I'll skip through it. Save yourselves the, but this allows you to load fonts. I've been tracking his work. He's got a library you can load fonts and display them, render them on through his displays. And this, I wonder if we're going to get to the next slide. Get to the next slide. Thanks. Sorry, folks. Right, and the only thing I wanted to talk to you all about was the next month. Tim's agreed to talk about his quadcopter that I mentioned right at the start. The problem is that Tim's in the US and it's going to be, and they go through a daylight savings change. He's agreed to do it anyway, but it's going to be 4 a.m. if we start at 8 p.m. for his talk. So I was just making sure that would be okay with you. And Andy, who may have just arrived now, it's usually the sort of time Andy will arrive. He also wanted to talk as well next month. So what I was thinking was perhaps starting the talks at maybe 7:30 and get Andy to start at 7:30, then get Tim to take over at 8 o'clock. So it'll be pushed a little late, and I probably won't do much for news or maybe none. Imagine all the time I'll have. Yeah, I was just wondering if that would be okay. Yeah, I think Tim's project sounds pretty interesting. So he wanted to talk. He was like, so would something like 45 minutes to an hour be enough? Yeah. I don't know how long we'll talk for, but yeah. But Andy will be talking as well. I'll talk to you in a minute about that. Oh yeah, and I just rendered some more images with Midjourney just to make everyone smile a bit. So this is MicroPython, small Python soldering mess of electronics or something. So yeah, it's fun. And that is it, my friends.